All right. Day 7 of Leetcode stream. Let's do this. Let me set up stopwatch real quick. Stopwatch. We're gonna take. Okay. Today I chose a sliding window problem. I just recently learned about it over the weekend, so that's nice. And I chose the best time to buy and sell stock, which is an easy problem. Pretty nice. As usual, 5 minutes. We'll do this. We are given an integer array prices where prices I is the price of Leetcoin on the ith day. You may choose a single day to buy one Leetcoin and choose a different day in the future to sell it. Determine the maximum profit you can achieve. You may choose not to make any transactions, in which case the profit would be 0. You may choose a single day to buy one Leetcoin and choose a different day in the future to sell it. You can only do a single day to buy one Leetcoin. Return the maximum profit. Okay. Alright, since this is a sliding, this is a sliding window problem, it should be O of n time and O of 1 space, where we only have to iterate through the list once using the sliding window algorithm. I already read the problem, and I kind of understand. I think I understand it. What it says. This price is for 0, 1, 2, 3, 4, 7 minus 1, yeah. Zero, 10, okay. Alright, we can start coding this now. Let's do this. Let us start stopwatch or planning. Okay. So let me go through with the first example, and we have an array of size 6. So 1, 2, 3, 4, 5, and then it's 10, 1, 5, 6, 7, 1. And we want to find the maximum profit we can achieve. Okay, with the sliding window algorithm, I know is that, yeah, we literally have a sliding window where we only look at like a subarray. So our best bet is to first look at the first element. So in this case, it would just be 10. I look at 10. And I say, this is my window I'm looking at currently, nothing else. Actually, no, I think I'm going to start with 2. So 10 and 1. I'm only going to look at 10 and 1. I'm going to compare the two. I'm like, if I buy 10, I could sell at 1. I lose 9. So I have to lose the least profit or make the most. I think I have to, or yeah, maximum profit. So in this case, I guess I could do like 1 minus 10, and I'm like, okay, I get a profit of -9 if I buy on day 10. and then I'll increase the window, because if I have the constant size the window, then I'm only going to be comparing 2 elements at a time. And if I do that, it's only going to compare 10 and 1, 5 and 6, 7 and 1, which is bad, because maximum profit here is like me -9. Maximum profit here is going to be 1. Maximum profit here is going to be -6. Maximum profit is 1. Okay, technically, actually no, it's not. Yeah, see, maximum profit is actually 6. So I have to increase the size of the window somehow. I could use like left pointer and right pointer. So like if I have like a right and a left and then a right. Actually, I don't like that. Left and then a right pointer. I'll increment that pointer right and have that be our window. So I'll open up the window to 5, and once again, I'll. Oh wait. Okay, I need to keep track of some like like max profits. If I keep track of some sort of int max profit, then I gotta keep it updated throughout the situation. I'm thinking like at any time. Okay, obviously after I include that right 5, I'm gonna include the right pointer. The left and right pointer will include everything up to that point. So 10, 1, and 5. If I want to get the max profit, I'll compare 10 and 5. And when I compare 10 and 5, I'm gonna be like, oh shoot, 5 minus 10 is equal to -5. -5 is greater than -9, so our max profit should be -5 now. Oh wait. Huh. If I get -5, I was supposed to say like move the left pointer. Move the left pointer. Problem is, how do I know what number to compare to? -5. Because I could only sell at a certain point. I can't sell like, oh, I have 5, I sell at, or I have 10, I sell at. I bought it at 1 and I sell at 10 now. And 1. Okay, I'll go back to this one first. I compare these two and I feel like, oh, I got -9. If that's -9, then that's my profit. I won't need to compare anything else, I think. Okay, and then I have another loop, or I have another block that adds to it. I'm like 5. And my window is going to be 10, 1, 5. Now I could check. My right one is going to move right, obviously. It's going to check 10 and 1 again, I think. Huh. Look at the problem again. Okay, if the max profit is that, then negative 9. If max profit is less than 0, then I shouldn't update the variable at all. I'll just skip it and continue the right pointer. So max profit is still 0. And then I move the right pointer. And now I compare. Is there a day where I can sell it at a cheaper? I'm just thinking of the brute force solution in my head where I just compare like I compare 10 with 1, 10 with 5, 10 with 6, 10 with 7, and then 10, and then you continue. That's an O of n squared solution. Oh shoot, okay. Huh. How would my sliding window work? Because I know it can't be constant. I have to somehow increase and decrease my sliding window. My thought is I'll keep increasing the window as long as there's as long as the current profit is greater than 0. Oh. I need to find some sort of way to get the sum of this or the profit in the sliding window without comparing each character against another or each integer against another. Huh. 1, 5, 10, 1, 5. If I make two comparisons, I get here 10 and 1 and 10 and 5. I realize that I can just move it like this, where the sliding is now just 1. 1 and 5. So left is still going to be there, right's going to be there. And I compare them, oh, the profit is 4. So I update that. And then next I do this. I'm like, okay, There's still profit there. So I still gotta do this. 1, 5, and then I do this again. Left point is still there, right point is there. 1, 5, 6. And I compare 1 against 5, 5 against 6. Or 1 against 5, and then 1 against 6. And realize, oh wait, the max profit's 5. Now. Well, if the max profit's 5, then what do I do with this 5 though? Because we have to return our maximum profit, but that isn't our maximum profit yet. I think we have to move the left pointer again. So it's gonna be like, oh, I found the second I find something greater than, I'll just do this. 1. You have 1, 5, 6, and the 7. And I'll just go, okay, now I just gotta compare it to 7. Because I already compared with 6, I already compared with 5. My left is there, my right is there. And so my profit's now 6. And now I'm like, okay, profit's 6, that's greater than the previous one, so I can just increase my right pointer again. 1, 2, 3, 4. It's now 1, 5, 6, 7, 1. And I'll compare it again. 1 here. Oh, that doesn't. That's profit 0. So, but I'm already at the end of the ray. The right point is already at the end of the ray. I feel like if I do this, this would require like a for loop inside a for loop. Huh. Let's say there's no profit in the first one. Let's say this is all no profit, 10, and they're all less than 10. Maybe I should use an actual left and right pointer. I'll start with the entire one first. Let's say I have ooh, this will be kind of tricky. Let me try this. You have 10, 1, 5, 6, 7, 1. What if I start the left and right pointer here? Because that would be over, and I slowly decrease them, but it's technically like a sliding window. Would it be? But I feel like this would just be 2 pointers though. A 2 pointers problem, not a sliding window. Huh. No, I don't think this will work. I think I have to go with my original approach. So my initial thought is, first we will have obviously initialize int max profit equals 0, and we first take a sliding window of two. Oh wait, what's our constraints? Price length is between 1 and 100. Okay. Well, I can just hard code the first condition, the first second. So if prices length is equal to 0, then we just return 0 because there'll be 0 profit. So yeah. Oh no, sorry, 1. Hopefully the condition holds true. Okay. And then once we agree with that, we're okay. So once we have at least 2 elements. Okay, let me change one more thing. If price length is equal to 1 or prices length is equal to 0. Because last time this happened, the condition was wrong. It was actually 0 between 100, not 1 and 100. So to make sure that we have our first box and second box in this case. So it's 10 and 1. And then we're gonna have a, I think, while no, I need a for loop for this because I need access to indices. So we're gonna do like a for, obviously int I equals 0, and then this time it will go to or I think prices, or existing prices, and then like I plus plus. Make the for loop, and we're going to iterate through the list. We're gonna have, oh yeah, we gotta initialize our left and right pointer. So we'll just say left is equal to okay, I don't need this for loop actually. I just realized that because left point right pointers, they just use the thing. So left is equal to 0, right is equal to 1, and now we got a while loop. So we're gonna have like a while. Okay, so now we're going to compare 10 and 1. Let me check. If we compare 10 and 1, we're going to calculate the, so I'm going to have like if I'm just say P for price, if price left or right minus price left is greater than 0, then, well, if it's greater, then that means that we can initialize our local, so max profit will be equal to actually no, not 0, sorry, just max profit. Greater than max profit, then we will have max P be equal to that, so it will just be PR minus PL and then once we compare these two, we're like, okay, we compare them and we're like, okay, they're not. We're gonna do else we're going to change the right pointer. Once we change the right pointer to 5, we'll now make a comparison again. So already, okay. I'm trying to see if it's O of n time, because this needs to be O of n time. So right here, 10 to 1, that's 1 compared. This is a size of list, so I'm just gonna say 6, O of 6 for now. Even though that really doesn't really mean anything. It's O of 6. And now okay, in the first round I made 1 comparison. Second iteration, I made, I'm gonna make 2 comparisons, or 1, 2, and then 3. So I'll make 3 comparisons. That's already a lot of comparisons. So we did 1 comparison, 3 comparisons. And I'm like, oh. Okay, I don't need to compare that. So I only need to compare 10 and 1 and 1 and 5, because I already compared 10 and 1 the other time. So 10 and 5, so that's just 2 comparisons. I'm gonna compare 10 and 1 and 10 and 5, or 10 and 5 and 1 and 5. Okay, and then I don't know what I don't know what to do with my code yet, because okay, let me just run through it. Oh, hello, Michael. Oh, you said bye. No, I missed it. I wasn't watching my live chat. Okay, it's okay. 1, 2, 10, 1, 5. And then I find, okay, sum is, the maximum thing is 4, so it's 4. Dang. Okay, we're at 25 minutes, so I'm gonna use a hint. Because I just got stuck. I'm like, okay, what if we compared, because here I have the statement PR minus PL, but that only applies for like 2 of them, 3 of them. I can't really compare just 10 and 5 and 1 and 5. How do I do that, like, generally? So I'm gonna use a hint. Okay, this is the brute force solution. I need a hint too. You should buy at a price and always sell it at a high. They're buying the price. I have no idea what the heck. So if you want to consider a selling value, you have to consider everything to the left as a buying value. So let's say we're with 1, we're with 10. Let's say we're with 10. Okay, there's nothing there, so 1. We want to consider 1 as a selling value. Do I have to buy at a higher value? And 4, okay. We are trying to maximize profit equals sell minus buy. The current buy sell value, we want to choose the minimum buy value to you want to choose the minimum buy value to the left or right. We want to choose the minimum buy value to the left of I to maximize the profit. Oh, this is pretty difficult. If I'm going to say my selling value is 1, what's the minimum value? 10. Okay. This reminds me of brute force though. Like if I'm like first comparing 10, I'm like I compare 10 with itself, or if it's, I don't need to compare 10 with itself. I can just skip that. I compare 1 with 10. Okay, that's good, right? My max selling value is just not going to be it because I'm going to make negative, so I won't do anything. And now I compare 5 with 1, and I'm like, oh, 5. This value minus that value is 4. I'm like, okay, that's good. That's 4. How about 5 minus the other one, the original one? Not so much. I lose negative 5. But why? What? Why is that? That's like comparing every single value against each other. And I do like, it goes to 6. And I'm like, 6 compared to 5. 5. 6 compared to 5. And then 6 has to compare to 1 and 10. That's like a brute force. Isn't that brute force? I swear that's brute force method. Am I not speaking out? Okay, it's already been 30 minutes and I still have like nothing, which is really bad. I did learn a sliding window, but oh my gosh. Sliding window for this problem is, even though this is an easy problem, I'm still really bad at it. Okay. How does that work though? Okay, let me just run through the my original thing first. So I had 1 comparison, and then I had 2 comparisons, and then 6. Wait, I just got another like thing. What if this was like 10 and this is like 100? Okay, no, because this one would take precedence. Okay, so I can just move it 10 over 1. 5, 6, and I compare with 1 and 6. That's one comparison. One comparison, I'm like, okay, 1 and 6, that's 5. So I can just, boom, 7, and I compare 1 and 7, that's 1 comparison. That's 6. Oh shoot, okay, now I have 1, I have another comparison. 1, 2, 3, 4, 5, 6. So that is O of n time. Okay, so my solution is O of n time with this specific problem. Let me try it with another one just to see. Okay, it's already been so long. Okay, I gotta start coding at one point. So just keep planning. Let me use the other problem, just like the one that had no solution, or no maximum profit. 10, 8, 7, 5, 2. Alright, let's do this. We have 10 and 8. We have one comparison, nope. Let's do 10 and 7. That's another comparison, nope. 10 and 7. 8 and 7, so that's 2 comparisons. And then I want to go here. I'm like, okay, 5. 10 and 5, that's another comparison, 8 and 7. 8 and 5. Okay, this solution is not working. It's not O of n. That is not the case. Okay, I might have to just watch the video at this point, because I don't know what's going on.
Hey everyone, welcome back, and let's write some more Leetcode today.
Oh, and
don't forget to hit the like button, it supports the channel a lot. So today let's look at Leetcode 121, best time to buy and sell a stock. So if you know a little about the stock market, the saying is usually buy low and sell high. So in this case, we're given an input array. Now each value represents the price of a stock at a particular day. And we are given one transaction, meaning we can buy on one of these days and then sell on another day. And we want a transaction that maximizes our profit, and then we want to return that profit. In this case, if we buy on day 2 when the price is 1 and sell on day 5 when the price is 6, that's what's going to maximize the profit for us. So as always, I'm going to draw a picture and show you that this problem is actually not too bad, even the optimal solution. So on day 1, it was at price 7, and then it went down all the way to price 1. The next day, it went from price 1 all the way up to price 5. And we could just keep going with this, right? So next day went down, and the next day it went up. And the last day, it went down again. So looking at the picture, it's pretty clear that the max profit we can get is simply by taking the minimum here and the max here. And if we look at the actual values for that, we see that this is 1, this is 6. So the profit is going to be 6 minus 1, which is 5. But notice how there's actually a greater maximum than this one, right? Like this is 6, but this is 7. So why can't we just do this? Because then we get 7 minus 1, which is 6, which is even bigger than 5. Well, it turns out we know that time moves in one direction, right? We can't go back in time to sell at this price. So how are we going to solve that problem? Well, there's a pretty common programming technique, 2 pointers. So we're going to initialize a left pointer on day 1 and our right pointer on day 2.
Okay,
I was
right kind of on the right track.
The right
left and right.
Left. And so we're going to see what's the current profit right now from here to here. Well, it's going down, right? That's not good. It's negative. And in this case, left is going to be the day that we buy, and right is going to be the day that we sell. So the first thing you're going to notice is it's down, right? It's negative. This is not good. We don't want a negative profit. Why would we buy left when we could buy right? Right is less than left. Why would I pay 7 when I could wait 1 day and pay 1? So that's basically how the algorithm works. Since our right value is less than left, we're going to update our pointer left. So left is now going to be on day 2 and right is going to be on day 3. So now we see that the right value is actually greater than the left value. But what's the profit? The profit in this case is going to be 5 minus 1, which we know equals 4, which is so far our current max. The profit in this case is going to be 5 minus 1, which we know equals 4, which is so far our current max profit. So for the current max, I'm going to put a 4. And in this case, since our left pointer is less than our right pointer, since we're buying low and selling high, that means we can leave our left pointer over here and we only have to update our right pointer. Now let's compare our left and right. So we're buying here, we're selling here. In that case, the profit is going to be 3 minus 1, which is only 2. So if you take a look at our current max, it's 4, so we're not going to update our max profit.
Okay, wait, I was on the right track with it, with this one, where I have a left and right. And I'm doing, okay, this price right minus price left is equal to price right.
And we notice that our
price right minus price left is equal to, or is greater than max price, and I'll do max price is equal to that. And then all I gotta do is update my pointer. So now I'll just write plus plus, and then else, you know, if you want my update, we'll just do left plus plus. Only problem is when they're both equal, let's say left plus plus and right. So I have to have like another condition. I'm like if left plus if left is equal to right, then I'm gonna say left plus plus and then right plus equal to, and then else. I have another else statement here. Else I'll just increase left plus plus.
left pointer, we're buying low and we're
We just
still
see the rest of
selling
the
high.
solution
It's
really
not
quick.
as high as this, but we still don't need to update the left pointer. And so now we get to the actual result case that we already know about, but let's compute it. So this is at 6. I'm gonna keep going even though which picture that we did find the max. So it's gonna end up checking this last case, which left we're buying 1 and we're selling at, I think this is 4. So for them is complete. And if we want to know the memory and extra space we used, we know we didn't really use extra memory. We used a couple pointers, but no array, so extra memory is 1.
So yeah, okay, let me just code this up really quick then. So I'm gonna do, obviously we have our int max sum, or int max profit is equal to 0, and then we have int left is equal to 0, int right is equal to 1, and I'm gonna be like while right is less than prices dot length, because we're entering to the end of prices dot length. We're gonna be like if say if prices right minus prices left is greater than 0, or max profit, then we will have max profit be equal to prices right minus prices left, and we increment our right pointer right plus plus, and then else we have another if. Same in here, if left is equal to right, and we're going to increment left plus plus, and then right plus equal to, and then else we will just do left plus plus, and return max profit. While right is less than price. Okay, let me just check while right is. So yeah, I think, okay, let me just run it and see what happens. Huh? What happened? What just happened? What? Wait, what? Oh. Whoops. That's what's wrong. I just had everything. I was like, what's happening? Why is there a syntax error? Or why is there an error with while? I did while everything right. Let me just indent everything so it looks nicer. So this makes sense. Okay. Okay, let me run it now. Hopefully it works. Wrong answer. Looks like I keep getting 0. What's happening? If price is right. So this condition is never executing. Why is that condition never executing? It's just 0. This condition is never executing, but that's impossible. Or is it? So it doesn't execute this condition because that's false in the beginning. Let me debug this really quick. Since it doesn't, oh wait, I do not want to do that. Okay, it doesn't execute. We'll just go over here, right here. We compare 10 and 1. Actually, saw it 7 1 5 3 6 4. 7 1 5 3 6 4 5. Okay. We compare left and right. We're like, okay, right is not greater than left, or it's not greater than the sum. So we end up skipping that, and we're like, okay, else, if left is equal to right, then we say, okay, left. Oh, sorry, that's not right. If left is equal to right plus 1. There you go. No. If left plus 1 is equal to right. There you go. Okay, now. It works. Okay. Sorry, that was just a little tiny error. I must admit it. And we got a wrong test case. Let's see. What happened? Oh, this is kind of funny. We only passed 2 of them. What? Okay. Let's trace this one now. I thought it was just one syntax error that I done messed up on, but I guess not. We have 7, so 1, 2, 3, 4, 5, 6. 5, 1, 5. Two, 3, 4, 5, 6. 5, 1, 5. 3, 4, 5, 6. 5, 1, 5. 5, 1, 5. Okay. I was just thinking about some random. I just saw it, but I guess it didn't work. 6, 7, 1, 10. Okay. What? Let me trace this code. I look at left and right. That's 5 and 1. I'm like, okay, 1 minus 5 is not. So, yeah. I increased left and right pointer this time. So left and right is now going to be that. And I'm like, oh, 5 minus 1 is 4. So 4 is our new pointer. And now we're going to increase right pointer. So we're going to increase the right pointer. It's going to be 1 and 6 now. So I'm like, okay, 6 minus 1 is equal to, oh wait, that's index 0, 1, 2, 3, 4, 5, 6. The length is 7. Okay. I go here, I'm like, okay, 6. That's the profit now. Now it's 5. The profit's now 5. And now I'm gonna increase my right pointer 1 again. And profit's 6 now. I'm like, okay. I'm gonna increase it again. And I'm like, oh, okay. 1 minus 1 is equal to 0. One minus 1 is equal to 0. And so as you can see, so max profit is equal to okay, when it encounters something's the same. I think I see the problem. When I'm comparing the two of the same ones, I should just continue. Right. I think I'll add another conditional. So like if price is right is equal to price is left, then I'll just do right plus plus, and then I'll do continue. Is that what's happening? Okay, maybe that's what's happening. If pass case 3, and there's another case I didn't pass. Okay, let's see what this is. So I got rid of the issue with duplicates, but not. Okay, 214. Let's use the test case. 214. So in this case, our max profit would be to buy here, sell 3. So 3. So left and right, we'll start with that. We're like, okay, 1 is not greater than 2. 1 minus 2 is actually negative 1. So we'll just increase our left pointer. So, oh, wait. Wait. I have to check if the right pointer, because if I the right pointer is right there, right? I can't increase right pointer by 2, because then it'll go out of bounds. I gotta check if right pointer is greater than, oh my gosh, okay, there's another one, okay. So we have another condition. We have if right plus 2 is greater than so in this case the next one, and this length 3 long. This is length 3. If right plus 2 is greater than prices dot length minus 1, then I'll only increase right. Wait a minute. Does this thing need to just be left plus plus? I might just be stupid. Oh my gosh, wait. Because if you're right here, increase 1, increase 1. Oh my gosh. Why did I not think of that? Okay, now I got that one wrong. Okay. This is creating more bugs for me, which is very unfortunate. Let's draw what happens here. 1 is not less than 10, so I'm like, oh, this is the same one back here, actually. We have 7, 1. 7, 1, 5, 3, 6, 4, 7, 1, 5, 3, 6, 4. Okay, look at this. We have our left pointer. 1 is not greater than 7, so we skip that. We increase our right pointer 1. Oh wait, no, we don't do that. We do left, right, right. That's what I did.
1 is 3, not greater than so for the current max, the pay and pay going to be on day 3. So now we see that the right value is actually greater than the left value. But what's the profit? The profit in this case is going to be 5 minus 1, which we know equals 4, which is so far our current max profit. So for the current max, I'm going to put a 4.
Whenever we don't hit the condition, we are going to okay. 2 is not greater than 3. then match profit. So I will skip that. I'll go. I think just greater than 0 actually. Will that work? Okay, still didn't work.
And in this case, since our left pointer is less than our left pointer over here, and we only have to update our selling here, in that case, the profit 2. So if you take a look at our current map, our left pointer, we're buying low and we're still selling high. It's not as high as this, but we still don't need to update the left pointer. And so now we get to the actual...
Okay, it's not 0 then, it's still max. So even I still getting the same output, okay. Now 1, 3, I'm like, okay. That's 0, and if let's say if I think, oh, it's the wrong thing. Please work, please work. Yes, it worked. It worked. I was trying to answer. Okay, that was a solution. Because over here, I'm realizing, okay, I keep updating the right pointer even though, or I keep updating max sum. I would only update it if it's greater than max sum. I wouldn't move the pointers at all, but I have to move the pointers even if they're greater than 0. Because, yeah, that's what's the one I'm looking for. Okay, that took a long time. This solution is probably pretty slow because it's kind of long. There's a lot of nested if statements. Oh, that looks really ugly. Sorry about that. But at least I did it. This is a sliding window. Wait, let me see how you did it first.
To be initial high, alt case. And we want to check well if preset as well as the profit that we just computed. So whatever the max is going to be assigned to the new max. Now, regardless of the conditions, we want to update our right pointer, in which case we result that we want to return. So if the left price is not less than the right price, we don't just want to shift our left pointer by 1, we want to shift it all the way to the right because we found a really low price. We found the lowest minimum. And our right was its L over right pointer.
See, that's a very short solution.
Really low price. We found all the way to the 1. If I actually had a small bug over here, instead of incrementing left by 1, if the left price is not less than the right price, we don't just want to shift our left pointer by 1, we want to shift it all the way to the right because we found a really low price. We found the lowest price that we could pretty much. We basically want our left pointer to be at the minimum. And you can tell from this picture that if our left was here and our right was over here, we don't just want to shift our left pointer by 1 because then it's up here. We want the left pointer to be low, right? We want to buy low, sell high. So we would shift our left pointer all the way over here. So we'd cross this out, put the left here, and then the right pointer would be over here, and we can see that this would be a super good profit for us. And now we can submit our...
Okay, that's it for today's stream. Good night.